Hello, I'm Eric, and in this video I'm going to be implementing a Python server and a JavaScript client for the Wisp protocol. The Wisp protocol is primarily used for tunneling TCP packets over WebSockets. In this video, that won't be my focus. I'm simply going to be implementing the Wisp handshake in this example code. And this example code, apart from this video, is going towards a project that actually won't be using the Wisp protocol for TCP tunneling. We're actually going to be using it for um, communicating between a terminal emulator and a process running on a remote machine. And that's handled by the Wisp extension for the Wisp protocol. I have to start a WebSocket server written in Python that just sends back whatever it receives, and a JavaScript client that sends a message and then prints out the message that it receives. And this is the output here. We receive a message on the client from the server that says the server received, and then there's the message that we generated on the client. So now that I have that established, it's time for the first step uh, of implementing the Wisp handshake, which is going to be the server sending an info packet containing information about the server. The info packet contains information like the Wisp version of the server. It's also going to contain a list of extensions, which for now is going to be empty. In the Wisp protocol, we have a packet type, which is a byte, and that's going to be info, which is number 5, followed by a stream ID, which is a 32-bit unsigned integer, and then the payload, which is arbitrary array of bytes. Each of these possible payloads, so let's find an example here. The extension data, for example, they'll have something like a payload length or some other information that you can use to get the length of a payload. So that's never ambiguous, the length of the actual Wisp packet, but it's not specified at this level, at least as far as I know. I've implemented the code on the Python server for sending an info packet. I used an enum for all of the Wisp packet types, and I added two functions. Create Wisp packet, which takes in the 3 arguments for the things that are in a Wisp packet, and creates bytes, and create info packet, which takes in, create info payload, which takes in major version, minor version, and extension data as per this, and also produces bytes. So I just use those together. I set payload in create Wisp packet to the return value of create info payload. I put await here and I didn't put await here. I probably need to, but this is empty, so it didn't. No, it's not empty. So that still worked. So this await isn't necessary there, and I don't actually know why, because I haven't used Python in a very long time. But we can see over here, this is the message that's received. I updated the client to remove toString. And we have 05, which is the first byte, the packet type. We have 4 bytes of 0, which is the stream ID of 0 in little endian, but in this case that doesn't really matter. And then we have the info payload, which is just the major version and the minor version. And the, where did info go? Major version, minor version, and the extension data, which it has a byte length of 0, so there's just nothing after that. Also, a quick correction on something I said earlier. The Wisp protocol packet length is known when you have the Wisp packet, and that's not because the length is anywhere in the packet itself. The Wisp protocol implicitly is on top of a transport that knows packet lengths. So the Wisp protocol itself does not specify how you know the packet length. It just specifies after you get a packet of a known length, what is the format of that packet. So I want to know if I remove this await here and restart everything, does that actually work? No, it doesn't, because it was never awaited. So I do need this await here. Aha! Okay, this is what it was. This is the type hint. So it doesn't really care if I um, do something that I shouldn't there. If I pass in I want to call it a promise, but this is Python. So I don't know if it is a promise. I think it's called like a coroutine um, creator or something like that. So if I run this now, it should also not work then. Yep, same error, right? That it should have been awaited. Um, can't concat coroutine to byte array. Oh, maybe it's just called a coroutine in this case. Thought it would have been like a coroutine factory or generator or something. Anyway, yeah, that works. So it was just because there was that await payload here, which honestly I didn't even type. Copilot put that there and I forgot about it, which is one thing that is really inconvenient about coroutine. For all of its convenience, it's almost always does something incorrectly or weirdly. In this case, this was correct, not correct to the type hint, but correct, and just not how I would have done it. So it made me a little confused later on. Before I proceed to the next step, I'm going to read over the handshake steps up to where we are now and to what's next. Uh, Immediately after a WebSocket connection is established, the server must send an info packet containing information about the server itself. So we've done that, except with no extensions. This includes information about the latest supported Wisp version, so for S 2.0, and a list of supported protocols. After the client receives the info packet from the server, it must decide if the extensions are compatible, and if not, it may reject the connection at this stage. At this stage is a good anchor point to the fact that we probably want some state. If the client chooses to reject the connection, it must send a close packet with a corresponding reason and a stream ID of 0 before closing the WebSocket. If the connection is to proceed, the client must send an info packet describing itself and the supported protocols. If the client chooses to authenticate itself, the credentials will be sent here. This part's actually kind of redundant. This is described in the auth extension for Wisp. So we want some state now to see if we're in the handshake, I suppose, phase of the connection. So that we know if the client sends an info packet, then we're able to accept it and then send the corresponding uh, who sends continue. Actually, let's see. If the client instead receives a continue packet first, version 1 of the protocol will be used. When the server receives the client's info packet, it will either accept or reject the connection. If the connection is accepted, it must send in a continue packet. So we're going to send continue. Yeah, so we'll need this state. If we're in this handshake state, I'm going to call it info state. If we're in info state and we receive an info packet from the client, we'll send continue. Just an addendum, here I'm strictly going to be supporting the Wisp 2 protocol only, although the specification seems to imply that a proper implementation of Wisp v2 includes the fallback to Wisp v1. That is implied by this line here where it says the latest version. I'm not finding it right now, but it's here somewhere. Latest supported Wisp version. So that implies we're not telling it what version of the Wisp protocol to use. We're telling it the latest version we support, which implies we should support v1. I'm not implementing support for v1, so this isn't a 100% to spec implementation according to the draft as it is right now. So here's the design pattern we're going to be used. You've probably used it before, even if you didn't know it has a name and an entire Wikipedia article for some reason. It's the state pattern. So we're going to have an object implementing the message handler for when we get a message on the WebSocket. Um, and we're going to replace the state with different implementations. So for the info state, we'll have a handler that sends the continue packet and then changes the state to the state when we're accepting connections. One thing I'd like to do is not implement a class for state and just say state equals info state and then have info state be the entire implementation of the state, kind of like how I would do it in JavaScript. So I'm going to say I want to do this in Python, and I'm going to ask ChatGPT because I haven't used Python in a long time, and the quickest way to do a Google search is to just ask the model that was trained on literally all the articles on the internet, I think. So I'm going to describe what I want to do. So we have info state, and then we have a function called handle packet, and it's just going to be some implementation here, handle packet, and say I will call this another state or data state. Let state equals info state. Can I make these object literals with methods in Python, or do I absolutely need to make a state class and corresponding subclasses? Let's find out. I can't put those functions inline though, can I? That's what I thought. So lambda functions have to be expressions though. The expressions, I want a list of statements. Is there a way to make a list of statements be an expression? That's the last piece that I need. Eval. Nope. Nope. Definitely not doing that. Okay, so that's just not possible in oh, this is equally gross. This is why I don't like Python. It's kind of awful that Python doesn't have this capability, and I don't understand why it does if it has Lambda in the first place. It really just makes me want to use I think it's called continuous passing notation or something like that, or continuous passing style. This. Well, this is showing the example in Lisp, which is kind of is there any other style in Lisp? Anyway, continuous passing style is the idea that that you're composing functions using other functions, and that's how you're building your logic. And that would make Lambda just as capable as multi-statement functions, but at that point, why not just write in a pure functional language anyway? So, I apologize for the disappointed expression in my voice. It's really hard for me to look at Python and not be disappointed, but I digress. I'll just write the classes. I have info state, which implements handle message, and it's going to send continue when we get the info packet. But one thing I want info state to be able to do is change this state variable. Now, if I had anonymous functions with lexical scoping, like I do in JavaScript, I could just implement this inside here and change state. I can't do that. So I think I have to make another class that holds the this state value and then pass that to each state that gets set on I don't even know if I could describe it in words properly, so I'm just gonna do that. Okay, this is what that looks like. So I have a state holder, and the state holder has an instance member called state, and it sets the instance of the state that we're in and passes itself as the argument so that the state can change the value of state on the state holder. And then we just do state holder state handle message. Gross. The continue message is very simple. It's just the packet type continue. And then there's a 32-bit integer unsigned little Indian for the number of packets that the server can buffer. So the number of packets we're allowed to send before we get another continue from the server to the client. The odd thing about this does limit the number of packets we can send, but the length of uh, the payload of a data packet, as far as I can see so far, is not limited. So I'm going to get clarification on that because uh, I couldn't see this being useful for having some guarantee about how much server memory is going to be used before we send another continue message to the client. And so I would probably, if that's the case, just set this to an arbitrarily high number and then not really deal with this mechanism for the use case that I'm building this for. Okay, two pieces of information. First, I realize TCP packets do have a maximum size. So the primary use of the Wisp protocol for tunneling TCP packets over other protocols like WebSockets, um, in that situation, you can assume the maximum like memory buffer you'd need on the server if you're counting packets. In response to my question with regards to TWISP, I actually got a response from the creator and primary maintainer contributor of the Wisp spec, who said, who suggested actually I could do exactly what I was thinking of doing, just setting the maximum buffer size to be the highest unsigned 32-bit integer, and then not actually implementing this behavior. Um, the phrasing here, though, says if I'm sure this situation won't happen. Basically, if I'm sure there's not going to be packet congestion. I'm not sure about that. I think maybe the WebSockets implementations might have some kind of back buffering, but then maybe they wouldn't have added this to the protocol if it did. So I'm not sure. I'm going to opt to just try it and see what happens. Okay, so we need to be able to send from the handler in a state, which means state holder needs the WebSocket object here. So I'll add that here. And all of these implementations uh, need the WebSocket object as well. So we can set that. And now I can send the info packet. So that's going to be, wait, self.websocket send, create Wisp packet, packet type, continue, and the payload is just going to be a 32-bit integer, which I can do by just doing that, I'm pretty sure. Uh, Lost my spot. Oh yes, right here. It's gonna be payload equals that, and this is just the maximum 32-bit integer. Uh, that's 4 bytes, right? Yeah. I'm specifying little endian in this case. Um, you can probably see why that doesn't actually matter. Quick note here, currently I'm assuming that the message I'm getting is an info packet. Really, I should be checking that. It might be a close. At this point, I have the happy path for the handshake working. So the server first sends the client an info packet with no extension data. The client then sends an info packet to the server, and then the server sends a continue packet back to the client. So this is how the JavaScript implementation looks right now. So very similar. I tried to keep it as similar to the Python code as possible, just to make it easier to maintain. So you have the packet type, which is like this enum here. And then we have function to create the Wisp packet and the info payload. And they just use uint data arrays to create that. And then we have the state thing. So I implemented it the way I would have liked to have also implemented it in Python, where we have a state variable and we define the behavior of each state. And states can do things like change the state to another state or access things in the lexical scope, which is nice, like the WebSocket. Where's the WebSocket created right now? That's actually created here. So technically, I think this should be up here. But I think maybe consts are hoisted to the top of the block. They must be, otherwise this wouldn't have worked. So then we go to state info at the initialization, and then when we get a message, we um, blindly assume the message from the server is an info message, create an info, send it, set the state to continue, which really means waiting for the continue message. And then again, we blindly assume the message is continue and move to the data state. So the next step is going to be parsing Wisp packets and then making sure we're actually getting the messages that we're expecting and closing the connection if we're getting a close packet type. I've added 2 new functions here to the Python implementation. Underneath create Wisp packet, we have parse Wisp packet, and underneath create info payload, we have parse info payload, and these take bytes and turn them into a dictionary of the individual pieces of information that are relevant to those things. Anytime I choose the order of definitions in code that I write, it's deliberate and it's making a statement. In this case, by putting each of the parse functions underneath its respective create function, I'm saying that I want this to be cohesive on these concerns, uh, rather than, for example, on creating versus parsing. The reason for that is because we could then put different definitions. We can more clearly see the implied schemas here, and we might later be able to, for example, write these as data definitions that imply the function that creates and the function that parses. These 2 functions exist from some implied object that describes the structure of a Wisp, right? In this case, it's the spec, and I'm writing the code by hand, but that wouldn't necessarily have to be the case in the future. Same with the info payload, right? These 2 functions, although one has the concern of creating and the other has the concern of parsing, um, they're both related to the same piece of data, which is the structure of a payload. And I see that as uh, the best way to, the best concern at which to make these things cohesive, if that makes sense. There's probably a better way to phrase that, but I'm not thinking of it right now. So handling the first info packet from the client is looking to be pretty verbose. So we check if it's a close type packet from the client, and then we close. And then we check if the packet type's not info. We should also send a close packet in that case because we're expecting an info packet, and that means we have a broken client trying to connect. Then we check the version and also close. I don't know if 4 is the correct close reason for this. It says incompatible extensions, but there doesn't seem to be something for incompatible versions. So that's what I'm going with for now until I hear back. Um, then I'm checking if there's any extension data present. I'm just going to say the server just doesn't support clients that have extension data right now. That will be changed pretty soon because I am actually going to be using extensions uh, with this implementation. But for now, for testing purposes, that's what it is. And then we send the continue packet. So this pattern's happening a lot where I'm creating Wisp packet of packet type close with 1 byte. So I'm actually going to create a shorthand convenience create close packet. So because I wrote packet instead of payload, um, this is going to be for creating the entire packet. Uh, and as soon as I appease Python's indentation-based nature, uh, reason 55 return. Okay. That should be a lot more convenient, so I can just replace these all with one line. Also, come to think of it, this doesn't really need to be async. Uh, a lot of these methods that I have that are async don't need to be. I just kind of set them that way for now because it was convenient. Major version 5? That can't be right. How did that happen? Info payload 5 is the number that makes this an info packet. So when I'm parsing it, that looks right, right? Or does it? Parse Wisp packet 5, 0, 1 to 5. This is a very confusing problem. I can see that the server is sending the correct thing because it's sending the major and minor version here. So this is definitely an issue with the client. So I'm just going to reload this and run the client again. And we'll see that I was trying to log this. I think I forgot to save the file. So we'll see that this buffer is 2 and 0. Actually, that's what we expect. Okay. So we'll log that separately and see if that's consistent. And okay, we get 5 from this thing that we logged. That's Claude was helping me out too. It says that the way I'm constructing data view doesn't make sense. It's expecting, what did it say? An array buffer, and I'm passing a uint8 array. So we're assuming that, no, it's data.buffer. Huh. It's a bit strange. What would the offset be? I'm gonna try what it suggests here and see if that works. And then maybe I'll have learned something about converting between uint8 array and array buffer. Look at that, this works. So I don't know exactly why this is how it is, so I'm gonna look into that and I'm going to explain it in the next video clip. Okay, so my first mistake is uint8 array is not involved here. I was getting too used to my convenient Python situation where my parsing functions take bytes as input and output an object, and the creating functions take some values as an input and produce bytes as an output. In this case, I'm working on uint 8 arrays when I create my data, and I am able to send that uh, through WebSockets. But when I get data, it's always a Node.js buffer object. And a Node.js buffer object has an underlying array buffer, and it specifies a byte offset and a byte length. And data view, I guess, needs all this information separately. It doesn't seem to support just passing in the buffer. Uh, I suppose because my guess is that buffer is a node specific thing and data view is also available in the browser, so they're just not compatible properly. And the reason why I'm getting 5 specifically is because I first parse a Wisp packet and I call .slice on the Node.js buffer object. I call .slice5 and that gives me these 2 bytes over here. Then I go down here and create go down where? Go down here. And before I had these here, I create a data view with the underlying buffer and I don't give it the offset information, which means it's actually here. So when I try to index the value at position 0, it's 5, which is not the major version, but it's actually the Wisp packet type. So that makes a lot of sense. I just got the fun error, set object is not subscriptable, and that's because I thought this was going to be an object with 3 properties with these names, because I have been writing in JavaScript too long where everything is happier and freer of redundancy, or it feels that way. I mean, the things that make Python convenient and wonderful to program in, I'm likely just not aware of at the moment because I'm trying to use it like it's JavaScript. Uh, but that's gonna fix that, right? Well, we still get an error, but it's a subsequent, not subscriptable error because of this one. I need to make a Vim macro, I think, that will do this part for me because this is a awful mundane task here. Oh, actually, I could have done like a queue register macro. That would have been the cool way to do it instead of what I'm doing right now, which is for the most part just hard to watch, especially because I just replaced my register. Okay, there we go. So click, 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 clickety, click, click. So we have this working. What do we have working? We have the server sending the client an info packet, which we can see here. And then we actually parse that info packet and we say we have major version 2. I didn't show this code in the client yet. Well, actually, I just fixed it, but I didn't show this code in the client previously. This code where we call parse info payload and check the major version. So we do that, and then we send an info packet to the server here. The server gets the client's major version and minor version, goes through all these checks over here, like the version check and that there's no extension data, and then sends a continue packet, and then we get the continue packet. And then the client, I don't have a print for this right now, but the client should be in state data, which means it can accept data packets now. Okay, so this went well in terms of outcome. I'm a little behind schedule now, though. I didn't think this would take as long as it did. So I'm going to end this video here as I end my work on this for the day. I'm going to slap a nice README on it, and I'm going to let a few people know that I'm developing this under the MIT license. Thanks for watching, and I hope this video was helpful or interesting.